Welcome to my first video on exploratory data analysis. I'm the data astronaut Hussein, and this is going to be a two-part series on EDA. First one is just going to be a quick theory on what EDA is, why it's useful, and how to do certain steps. And then the second video, I'm just going to get a data set and do basic EDA and show you the foundations, and then you can explore further and understand different libraries and understand how to deal with certain things like missing data, feature engineering, and so on. Before we get onto the other slides, I just want to quickly talk about theory and application. And I just want to say why it's so important to apply the knowledge you gain as you're learning. So if you learn the theory for whatever it could be, for example, if it be just learning the Python programming language or data science or analysis, if you do just theory for weeks and weeks and months, for example, just taking notes, writing down different sections, when it comes to actually solving real world problems or going into a job and applying your knowledge, you're not really going to know how to tackle certain problems. But if you're doing projects, for example, working with small projects on your own, learning while you're applying the knowledge, you're going to be always hitting these certain issues, problems that you otherwise might not be seeing. And working with these, getting this little understanding on how to deal with, for example, missing data. And when you're working with more complex data or in a business or doing a big project with your data science team, and when you come across these same problems again, you have the basic understanding and you would have built that problem solving capabilities early on, and you'll know how to tackle these problems, and you won't just hit a brick wall by just knowing the theory. So I just want to stress the importance of learning theory and applying it as you go along. Keep doing projects, that's the best way to learn. And when I used to teach maths, I used to tell my students, keep doing practice papers, keep doing practice exam questions, because at the end of the day, that's what you're going to be answering in exams. So learn how to tackle these problems, learn how to solve these problems. And same goes to this, don't just learn the theory, learn how to apply it. Do different problems, keep doing projects, find little projects online. And I'll be myself making a lot of videos on regression, clustering, classification, using various different algorithms like logistical, linear, k-means, k-nearest neighbors. And we're going to be working on different data sets, for example, house prices, predicting house prices. And hopefully you can see a lot of, you can build a lot of the foundations and get into like an intermediate level at least with my videos and how to solve certain things. And I'm hoping to give a lot of insight into data science and data analysis. But yeah, keep solving projects, keep doing different things, learn and apply your knowledge. It will help you with retaining a lot of that information you're gaining. And yeah, so the contents of this video would be what EDA is, key steps in the EDA process, some of the Python libraries used, and a summary. So what is EDA? So EDA is all about getting curious about your data, is a crucial step in the data science process, and these are some of the stuff involved in EDA. So examining and understanding a data set, gaining insights from data, identifying patterns, trends, and relationships. So all of these you can do by making graphs, plots, and other visualizations just to understand it a little bit better. It'll be easier to understand graphs and plots and visually see changes over time than just looking at a data frame with maybe thousands of data points and rows and columns, for example. It helps you get a feel for your data and its characteristics. It outlines potential issues, outliers, or anomalies. And you can do this by like box plots, for example. I'm sure I'll be showing how to do this, but I'm sure a lot of people learn box plots in GCSE maths. You work out the interquartile range, all of this stuff, and you spot any outliers from your data set. And then finally, it's important for data quality assurance. EDA is important for data quality assurance. So EDA is the important first step into analysis and model building. It helps formulate further questions and areas for investigation, and always uncovers aspects of your data that you otherwise wouldn't have seen. And here's some of the key steps. So data collection. Gather necessary data from various sources such as databases, spreadsheets, or just scraping data from certain websites. For example, data scraping, one of my projects I It's a personal project. I just classified if a picture of a person looks happy or sad, and I just got a lot of use a tool to get hundreds of pictures from Google of happy people, sad people, and built a model that can classify if a person is happy or sad just by the picture, and it worked pretty well. So gathered the data myself and built the model, and I'll be showing how to do that in the future. Data cleaning, this is a very important step. It includes handling missing values, dealing with outliers, removing duplicates, inconsistencies, or errors. So talking about my classification project that I just did, I removed a lot of data that was below, for example, 9 megabytes, small unclear images, so I could, my algorithm could get more detailed images. For example, well, data cleaning is a big process. If you're not going to feed your algorithm good, clean data, it's not going to produce any, good accuracies. So whatever you feed it, it's going to produce something along, the same level, I would say. So poor data feeding into your machine learning algorithm will mean poor accuracies at the end of it. So data cleaning is a very important process in anything, just visualizations or making machine learning algorithms and so on. And then we have data exploration, examining the data set using statistical summaries. So you work out the mean, median, mode, for example, see the relationships between your data. Then you do like visualizations, histograms, scatter plots, box plots, and other techniques can be used to visualize your data and understand it further. And then we have feature engineering. Based on insights gained from earlier steps, you may need to engineer, remove, or create new features. So I'll quickly tell you what a feature is. So it's basically if you have, like, let's say house price data and you have column names, the year built, the price of the house, number of bedrooms, does it have a garage, all of these are called features. They're the features. So the column names are your features. And how to, like, one quick example of feature engineering you could do, you could just remove some of those, combine those features to one, or add or create your new features. So for example, with the house price, I just said year built of a house. For example, the rows would be 1997 for the first house, the second house was built in 1999, and so on. And this, when you're visualizing it, it's just going to be, the data is just going to be all over the place, and you're not going to be able to see any trends, for example, and it's not going to be too appealing to look at. However, if you engineer your columns, your data, let's say you create a age column, and to find out the age, all you have to do, for example, in 2023, you do the age column minus the year built column. So 2023 minus the first house was built in 1977. Now you have the age of the house, and this will be a lot more important when you're feeding into algorithms, or even just visualizing it. You can see a lot of trends when you're visualizing this. It'll be a lot better. But for example, when you're putting into algorithms, you can use this to see, how does the house age affect the price of the house, and maybe you'll get insights such as the newer builds are worth a lot more than the older builds, and so on. So that's one way of doing feature engineering, one example. And then we have hypothesis testing. Testing hypotheses or assumptions about your data. You can use statistical tests to determine relationships between groups or variables or features, so correlations, outliers, and distributions. And then finally, communicating your findings. So this is, I cannot stress how important this step is. You could be the best data scientist, best data analyst, and so on. Like, you could be an expert in your field, but if you can't communicate your findings, even if you make the best machine learning algorithm, if you can't prove that this algorithm is going to make a big difference in the business process, or it's going to give you, a certain improvement, or it's going to be worth it to use this, then that's a waste. That's a waste of your time. So your stakeholders, your managers, your data team, sorry, I didn't read that. So effectively communicate findings to others such as your data team, managers, and stakeholders. You can use reports or presentations which include visualization. So if you can't be able to communicate your findings, show them reasons for why you did certain things, why you chose a certain algorithm, or give them insights into the data you found, or your findings, or anything like this, if you can't communicate these, they're just gonna scrap the project. They're not gonna, want to take the risk, for example. So a quick example: when I was younger and first getting into data analysis, I was analyzing our company data, my dad's businesses, and he used to always put it on physical pieces of paper, and it was never useful. You never understood anything. And I was making graphs. I started to make graphs of it, saying, look what I did, showing my dad, and he would never be happy because he would just say to me, what's the point? If you can't show why what you did is important, then there's no point. So you have to, gain business insights. Look at the key performance indicators and make predictions for the future. So your algorithms and your findings can be important, and you have to communicate these really well. For example, you can make, spreadsheets or presentations, reports. You can make Power BI dashboards, and here's an example of that. So you have a hotel revenue management, you have the KPIs, key performance indicators, customer data, agents, this and that. You have the revenue by month. And for example, if you are showing this to your stakeholder and you show this, they might want to, this is very great. They'll be like, okay, why are we seeing higher revenue in August? And if you're like an ice cream firm, for example, summertime people are buying more ice creams. Just a quick example. But you need to be able to communicate your findings, make it easier for your stakeholders and other people to understand what you have done. And yeah, this is an example of how to do certain visuals, and Power BI is very important, I would say, and it's really nice. You can do live reporting as well, and many other things with this in your business. And let's move on to the next slide. Libraries used. So these are just some of the libraries we'll be using in the future, but Pandas, NumPy, Matplotlib, Seaborn, these are more of the basic ones. Not basic, but the ones that we'll be using. There's so many other libraries, newer ones coming out. Like for example, Matplotlib is like a 20-year-old library, but yeah, you can still use it for statistical analysis, making certain graphs you need. Pandas, great for working with data frames. It'll be very important. So one thing I'll say before watching the next video, not learn what Pandas is, but just like a EDA video I did, just see what Pandas is. I'll be explaining it while I'm going through it, but it'll be nice. And if you have a basic understanding of Python, I feel like you're set to go with my videos, and we can work with certain projects without an issue. And a quick summary: EDA is an essential step in the data science workflow. It allows you to gain insights, understand the data, identify patterns, validate assumptions, and ensure data quality. By performing EDA, you lay the foundations for further analysis and decision making in your data science projects. And this is it for my video. Thank you for watching. I'm hoping to do a lot more of these videos where I'm giving you a basic theory and then applying the theory. We're going to be applying a lot of theory. We're going to be doing a lot of different projects. I have so many plans out. I guess my first one's going to be linear regression, how to do linear regression on a certain data set. However, in between I'll just be doing like certain findings I have. So for example, I've been recently working with ChatGPT, doing like sentiment analysis with different models, and I'll be showing you how to use GPT 3.5 Boost, for example, or like the Da Vinci algorithm, and these other ones like Stable Diffusion to do cool AI stuff. I'll be adding all of these fun videos, short videos in between, but I'll be mainly focusing on teaching from the beginning, different algorithms, different ways to work with data and make machine learning algorithms with that, and doing data science projects. Thank you for watching, and I'll hopefully see you in the next video.